Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 27. So last time we went through a Canvas related sample called Hello Canvas Transform. Today we're going to go through an elaborate sample that actually applies Canvas transforms. So let's launch this sample. It's called parking. As you can see, we have a bunch of parking locations. Kind of like in a garage, like a garage of a building, and A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and then we have multiple floors. This is floor number 1, floor number 2, 3, and 4. They're all the same. They all have the same pattern. So in order to book a parking, assume this is a machine and the user sees a screen like this, and then they can touch it. Without a touch screen though, it could be done with a mouse. So if I were to click on the letter E, it says floor 1 parking spot E is booked. That means I couldn't book it again. However, I can go to the second floor and book E again if I want. And then book, let's just say the letter L. Now if I were to go back to the first floor, only E is booked. But on the second floor, E and L. On the third floor, I can book C, for example, and on the fourth floor, I can book O and P. So as you can see, it's just a simulation kind of application. It's not a real app. It's just simulating the parking reservations. In a real app, you would assume that it would also accept payment as part of the process. But in any case, as you can see, we have a bunch of parking spots here as far as the design of the app, but then you can see the same exact pattern is repeated here, except it's sideways. So it's rotated by 90 degrees. And then here it's rotated by 180 degrees. Here it's rotated by 270 degrees. That might not be the best design as far as the way I'm showing the letters. For example, I'm showing them upside down here. Normally you would probably not do that, but for the purposes of demonstrating transforms, this is a perfect application of how transforms can be helpful. So I mean, basically what we do is we build 4 parking spots and then we rotate them by 90 degrees. We rotate them by 180 degrees and then by 270 degrees, and that's how I end up with 16 parking spots. In order to rotate them in a way where they would remain at the edges of the canvas, I'd have to rotate them around the center of the canvas, and I'll show you how that could be done with a transform. So let's take this to the side, keep it open, just so we can take a look at it while reading the code. And then let's start looking into the code. So we have a parking app that's a custom window. And it's got a presenter. So before body, we set up a parking presenter, and all it takes is the floor count. So we have 4 floors to begin, and the canvas length, because it's a square canvas, is 600. So that means it's 600 by 600. So length is both the width and the height. Next, we look at the body of the application, and you can see it has a title of parking. It's got a label at the top. It's got a spinner. The spinner is using bidirectional data binding. It's data binding its selection attribute or property to the selected floor attribute on the parking presenter model. So that means whatever value I select here ends up persisting in the model. So right now, for example, the value is number 2. And then here it's saying on widget selected, meaning on trigger of this listener. So I'm using both data binding as well as also listeners at the same time. Sometimes that's useful. The data binding is just persisting the data to the model, but then here the listener is taking some sort of an action. So it's kind of like a mini controller. And what it does, it basically clears the canvas of any shapes. It calls the dispose shapes method, and then it adds a new content to it, which is a new parking floor. So that happens on every floor change. But I mean, before we get there, how did the canvas get populated to begin with? basically we have a canvas here that has a canvas, a width and height of the same length. It's got a background of dark gray. That's the background you're seeing over here. And it basically has a parking floor on it. So the nice thing about Glimmer DSL for SWT is that you can use methods to abstract concepts out into keywords, and then you just use the keyword over here. This is called the method-based custom widget approach, meaning I'm building a custom widget by using a method. There's a different approach also, which is the the class-based custom widget approach, which we'll see in a future tutorial. But for now, we have a method called parking floor. It's built out of four parking quads. And then as you can see, well, every parking quad has a location X, location Y, and a length. But also it's got a degree, an angle that represents how rotated it is around the center of the canvas. So 0, 90, 180, 270. And here you can see in the parking quads doing some calculation, but then here it basically builds 4 parking spots. So again, the beauty of methods, using methods as a way of abstracting custom widgets, is that you give them very useful, friendly names like parking floor, parking quad, parking spot, and then you compose them out of each other. So a parking quad is 4 parking spots, like these 4. A parking floor is 4 parking quads, so all 4 of them, all 4 quads, etc., etc. So it's a very a good way of composing visual concepts. Finally, parking spot is where most of the work happens. It's got a few calculations. It's building a rectangle, effectively. That's the end result of it. It's a rectangle with 2 lines around it. And the background of the rectangle is using data binding as well, except it's unidirectional data binding. And it's basically saying that if the parking spot for the parking letter that it's on, like let's just say the letter E, is booked, so the attribute is booked on that model, then it'll basically check what the value is. If it's red, if the value is a Boolean of value true, then it'll color it red. Otherwise, it'll keep it colored dark gray. So that's what distinguishes the booked from the unbooked spot. And it's got a text shape underneath. The X and Y are defaults, meaning they're centered within their parent. So that's why the E or the D here is centered horizontally and vertically within its parent. So this is heavy lifting that Glimmer DSL for SWT will take care for you. You don't have to program the math for that manually. But eventually there's an on-mouse up listener, and that basically gets triggered when I click a button and then release the mouse, so on mouse up. And that will basically then call the selected parking floor method, and then it'll book the parking spot letter. And if we were to go down, we have this method parking spot for that will basically select based on the floor that we're on. It'll select the parking spots and then pick the one with the right letter. Selected parking floor will actually pick the floor based on an index related to the spinner value over here, and it'll select it from the parking presenter. So it'll select the right floor, and then it'll select the right parking spot, and then it'll do the work over here. We got lines around the rectangle, but the key thing now that we're going to focus on is the transform. So here it says rotate around the canvas center point. Basically, the way to do that is you do a translation first towards the center of the canvas, and then you rotate it, and then you detranslate back. So that's how you do a rotation around the center of the canvas. So if you do that, if you do a translation to here, you rotate and then detranslate, it'll basically rotate it around the center of the canvas. And you'll get to learn a lot of these things by studying the math of linear algebra, affine transforms, linear transforms, and geometry. But this is one way of basically allowing you to take advantage of transforms in order to simplify the creation of the other parking spots around the main parking. So I mean, the top is the basic way we're drawing the rectangles with the letters within them, and then those are just replicated versions of it that are rotated 90 degrees, 180 degrees, or 270 degrees. And here we're just generating the letters one by one by calling the next parking spot letter, which is just a low-level detail. It's not something that important, but it happens over here when we're building the parking spots. That's how we pick the letter using this method. It'll basically give you the letters from A to, let's see, to P. So one key thing, another key thing to know about is basically when we change the parking floor over here. So I go to the second floor, for example, or the third floor. It'll basically change the value on the model, and then here immediately destroy the canvas data and redraw it, rebuild it by reopening the content of the canvas and laying out a new parking floor. And a parking floor will automatically use the right data from the current selected floor in order to populate itself. So that's why it basically knows that here for every parking spot, it'll find out if it's booked or not by picking the data from the model, and it'll end up coloring it red here. So like on the third floor, let's just say I pick O and M as well, and then I go to the fourth floor. See, it remembered what the fourth floor had, but then if we go back to the third floor, it remembered what the third floor had on it. So this is all done through data binding by letting it automatically pick this data from the model. So it's all declaratively happening through data binding. This is pretty much it. That was a pretty good example that demonstrated the benefit of canvas transforms. In order to learn more about the Glimmer DSL for SWT project, check out the GitHub repository.